Welcome back one more time, and this is going to be the last part of submodule 01. And in this particular submodule, we have already seen a lot of basic concepts about physics, and especially the ones that are required for jet engine. And in this particular series, we will know about only the exact types of engines that are fitted on aircrafts. And in before going to that, we will just go through one by one, and it's just hardly 2 to 3 pages only, so it will be a short video. So another common nomenclature describing the various sections of a turbine engine are known as the hot section and the cold section. Now, see, last video you have seen what are the different sections of an engine. So I'll just tell you how is the two sections of an aircraft jet engine is actually considered as. Like, the cold section is basically that part, that is the inlet, the compressor, and before and after that there is diffuser, and we will come to those one by one definitely when we are just describing in a great detail about the jet engine in next upcoming all videos which will be coming next. So right now, for you just to know that cold section is that particular section where there is no heat added or there is no ignition. So hot section starts from combustion chamber, and then it will go to your turbine and then exhaust. So this is the hot section, okay. And the cold section is basically referring to the inlet, from the inlet till the diffuser, okay. Major components of gas turbine engines are basically the same. However, nomenclature of the component parts of various engines currently in use varies slightly due to the difference in each manufacturer's terminology. So generally the components are of various, like there are several parts and different types of things that have been used in a jet engine, and most importantly these are named according to their particular job or particular work that they do. So various manufacturers may have various terminology, but normally they are all same, okay. Now these differences will be reflected in the particular manual in which you will be following, particular engine maintenance manual, okay. Now, what are the types? Okay, coming to this types, see, one of the greatest single factor influencing the construction features of any gas turbine is the type of compressor or compressors for which the engine is designed. So, four types of gas turbine engines are used to propel and power the aircraft, and they are turbofan, turboprop, turboshaft, and turbojet. Now, from the name, one thing is common, you can see it's turbo. Turbo means it is related to turbine, as these engines are having turbine which is producing the power, mechanical power. So mechanical power to rotate the shaft, okay, on which the blades are mounted. So it can automatically generate its own power to drive the shaft and then rotate the blades. So that is the reason they are all called turbo. Now with the word turbo, you find over here, you can see that there is four different words. One is turbofan, second one is turboprop. Prop means propeller, which you all know, and then turbo shaft, okay, where the shaft work is the most important thing, where we basically use the engine to actually produce some shaft power, and then turbojet. So now turbofan is basically what you see in Airbus, Boeing, all these aircrafts, because there is a big fan in front of the engine, the big large diameter fan. The engine is basically responsible to rotate that fan, and that fan is responsible to produce the thrust, okay. I mean the major portion of the thrust, and very minor portion of the thrust is taken from the exhaust gas, the hot exhaust gas of the engine. Now turboprop, in turboprop we have got propellers. So propeller will be producing the thrust, and engine, turbine engine, will be rotating the propeller, okay. Turbo shaft, in turbo shaft there is a turbine which will rotate the particular shaft through some gearbox mechanisms and all, and that shaft will further drive a propeller, or maybe it may just run a compressor. It can do several other types of works. Then there is a turbojet. This is something that is used in fighter aircrafts. Generally in modern aircrafts you will not get this, because turbojets are having very good efficiency. We will learn about all these things in future also, but turbojet is basically having a lot of fuel consumption more than turbofan. That is the reason turbofan is normally used nowadays in all commercial aircrafts. turbojets were used previously. Now also there is some usage in civil, but quite less, as these are basically very high thrust producing machines which are basically used in defense. Okay, that is in fighter aircrafts, because they can produce Mach or I mean the supersonic Mach range about 3 to 5, something like that. Okay, I mean 3 to 5 Mach also they can reach in some aircrafts. Like we have got Rafale in India, we have got Tejas, we have got Sukhoi. So all these aircrafts will be having turbojet. Now the term turbojet is basically a turbine engine that is producing a jet, a hot jet. So the entire hot exhaust gas over here is basically responsible for producing the thrust. Okay, that is the reason it is called turbojet. So all these four words, I guess it is clear to you now. Fan stands for the big fan that is mounted with the engine, which is rotated to produce thrust. In turboprop, propeller produces the thrust. In turboshaft, we basically want the shaft work, and in turbojet we want the jet to be produced, the high speed jet going backward from the engine, which will produce a forward thrust. Now okay, sorry. So turbofan will be producing about 80% of the thrust from the fan itself. Okay, from the fan almost 80% of the thrust will be produced, and 20% you can expect to be done by the core engine, the core turbine engine. We will discuss this one by one, everything. Now, okay. Now what is a spool? That is the second thing that you should know. See, spool is basically one shaft in which in one side there is a compressor, on the other side there is a turbine. This is called a spool. Sorry, just a minute. The picture is it's a bit hazy. Okay, I hope it's getting clear now. See, the green color shaft that you can see, the green color shaft, see that green color shaft is having on the left side compressors, on the right side turbine blades. Okay, turbine rotors and compressor rotors, on both the sides it is there. And there is a purple color shaft you can see around the green shaft, that is having the second stage of compressor and the first stage of turbine. So in this particular thing, one single arrangement of one shaft having compressor at the other end and turbine at the other end, okay, is called one spool. Means one shaft with compressor and turbine at both ends is one spool. That means green color is one spool and the purple color is another spool. Okay, so there is two spool. So which means this particular engine is basically a two spool engine. It may be three spool engine also, where there can be three shafts mounted over each other, and there can be three stages of compressor and three stages of turbine. Now the very first stage of compressor in the left is called low pressure compressor. Then you have got the purple color high pressure compressor. Okay, see in the nomenclature, in the labeling also it is given low pressure compressor, high pressure compressor. Then you have got on the right side, it is the low pressure turbine. Okay, and there is high pressure turbine. Fine. So the inner shaft or the inner spool is basically the high pressure spool, and the outer green color spool is the low pressure spool. Okay, so two spool, low pressure spool and high pressure spool, or you can say in modern engine it is basically denoted with N1 and N2. N1 means the low pressure spool and the N2 means high pressure spool. Okay, so in cockpit you can get N1 RPM and N2 RPM, means with what RPM is the N1 shaft moving or the low pressure shaft is moving, and N2 RPM means with what RPM is the high pressure shaft moving. Fine, we will discuss this in a clear form, in a detailed way. For now, just for your basic understanding and to clear this particular thing, I'm just finishing it off. Now the low bypass turbo fan engine. Okay, now what is bypass, that also we will come across. Okay, these things you can just go through, it will be covering up everything. Now just going to one by one. See, this is the turbo fan engine where there is a big fan mounted at the front. So basically the engine is responsible to rotate the fan, because fan will be producing the maximum amount of air. Okay, sorry, maximum amount of thrust. Then turboprop, in this particular engine you can see a lot of gearbox and all these things are there, because it is to produce a high torque to rotate the propeller, because propeller over here will be producing the maximum amount of thrust. In turbojet you can see there is no big fan, no big propeller, it is the whole core engine that is producing the huge thrust that is required. It is generally quite long, you can see, and it's having a very streamlined shape. It is quite long, and that is the reason it is basically it almost feels like a rocket. Okay, and it is easy to put in a fighter jet. It is very streamlined, so it doesn't cause a lot of drag, and the aircraft also becomes very narrow. Then you have got a turbo shaft, which is basically in modern aircraft it is used as a APU, auxiliary power unit. You all have heard about APU. It is a sort of a third engine that we have. It is like a rescuer. It is like an emergency unit. Okay, you can call it as anything. It can produce air power. It can produce, electricity. Okay, so whenever we require that in flight or on ground, okay, time to time basis. So that is turbo shaft. Here basically one thing that is required is a shaft. There is a power shaft, purple color, which is going out from the engine on the left side. You can see towards the exhaust. So here the shaft is a very important thing. So that is all about it. Now coming to this one, see they have talked about over here about the bypass flow. From here you can understand what is bypass. Now by the word bypass we can understand something that is passing by. Okay, let's say you are riding a vehicle and there is a car which is overtaking you or bypassing you from your right, okay, or from your left, let's say, which means they have bypassed you, which means they have crossed you. Okay, without affecting you they have crossed you. Now over here you can see there are two flow of streams. Okay, there is a flow that is getting inside the engine through the compressors, the blue color stream of line that you can see. Then it is getting burned with fuel and everything in the combustion chamber, and finally going out as a red arrow through the exhaust. So that is the core flow, which is called the core engine, the basic engine, which is responsible to rotate and produce the thrust. So that is the core flow. It is that air is responsible to run the engine only. Okay, so that is about 20% only. And see, the fan is also drawing air which is in white color through the outside, right? Through the outside you can see from the bottom and the top part there is a white color line or white stream of air that is bypassing and finally leaving in blue arrows on the right side. Okay, which is bypassing the core engine, you can see from the top and the bottom. So now imagine this is bypassing the, you must have seen, if you have seen an engine, there is a core engine and there is a outer side section also, right? So this is basically that particular thing that they are talking about, where the air is bypassing the core engine, and that is the reason this particular air is called as bypass air, and it is about 80% thrust producing. Means this is basically responsible for producing about 80% of thrust in modern engines. Okay, so that is called the bypass air. So it is basically the air that is bypassing the core engine. Okay, now what is called as a gas generator, if somebody asks you, it is basically the thrust produced by the fan more than makes up for the decrease in the thrust of the core or gas generator of the engine. Now what is a gas generator? Gas generator is basically the compressor, the combustion chamber, and the turbine. Okay, compressor, combustion chamber, and the turbine. These are the three or four. You can also consider the diffuser also in between. So from the basically from the compressor till the turbine, this is the gas generator. Gas generator means something that is producing the gas. Okay, gas is what? It is the burnt air only. Air burnt with fuel. That is only gas. Okay. So who is producing the gas? The compressor is compressing it. Diffuser is diffusing it. Combustion chamber is burning it, and through turbine it is going out, expanding, and then finally going out. So the entire process, okay, from compressing till exhaust, is basically the portion where the gas is produced. Okay, all these processes are went through and the gas is produced. So that is called the gas generator. Why I am repeating these again and again? Because there is a DGCA question based on gas generator. So you should know what is a gas generator. It is basically that particular portion of the engine, the basic core engine from compressor to the exhaust, which is called as the gas generator. Okay. It is not the fan or anything or the propeller. It is the basic core engine. Now there are two different types of exhaust nozzle designs which used with turbo fan engines. The air leaving the fan could be ducted overboard by a separate fan nozzle, or it could be ducted along the outer case of the basic engine to discharge through the mixed nozzle. So there could be two types of nozzle, basically a separate nozzle and a mixed nozzle, in which the air, like over here you can see, it is finally mixed outside, or it could have two separate zones. See, over here the bypass air leaving from the top and the bottom is having a different duct, and the core air is having a different duct. So over here you can say like they are not in a single nozzle, they are having different nozzle. But let's say if we had a single nozzle, then both the airs, bypass air and hot air, would have been mixed together and finally left out from the engine. Okay, we will definitely discuss all these things in detail. And the turbo fan is a compromise between the good operating efficiency and high thrust capability of a turboprop, and the high speed, high altitude capability of a turbojet. So basically, turboprop is a very good engine for the lower altitudes, okay, and for regional flights. That is the reason you will find ATR aircraft, Q400 operated by SpiceJet or Indigo, and ATR operated by Indigo. These are basically one of the best aircrafts for the local connectivity, because they don't have to go to a long ceiling altitude. For regional connectivity of 45 minutes to 1 hour, they are the best. Okay, because they produce a lot of propulsive efficiency because of that big propeller. Equally, if you consider a turbojet, it is very good for the defense aircrafts, as I told you, to get a lot of high speed. Now, turbofan is basically sort of a, is a mixture of both. Is a mixture of the turboprop as well as it is a mixture of the turbojet also, which means it gives you good speed like turbojet, okay, and it also gives you very good propulsive efficiency because it is having a big fan like a propeller. So it's basically a mixture of both. It is like you have put a big propeller to a turbojet engine. It is sort of that type of a mixture. Fine. So that is the reason it can give you all best type possible things. You get a good optimum speed, you get a good altitude, you get very good thrust specific fuel consumption, which we talked about in last videos. So everything is good, fuel economy to everything. Okay, so approximately 80 to 85% of the energy developed by the gas turbine engine is used to drive the propeller, and the rest of the available energy exists as thrust. Okay, so basically in certain engines where there is a big propeller or there is a big fan, just know this, that whatever the energy that is produced through the hot gases by the turbine, that is the shaft work that we have talked about, that shaft work is mainly responsible to rotate the compressor so that new air or fresh air is again drawn inside and the engine becomes self-sufficient. Self-sufficient means the engine can rotate by its own power. We do not require any generator or any motor or something else to put into it and then rotate it. Okay, it can rotate on its own. So that is the reason you need to rotate the turbine. If you rotate the turbine, that will rotate the compressor because they are in the same shaft, as you can see here. Okay, so that is all about it, not going into depth. And turbo shaft they have talked about over here. See, again they have mentioned the word APU. So once we just head on to the basic, the core chapters, we will discuss everything in detail. Don't worry, and I'll try to come up with such things where I'll be drawing things, if possible, with my own, like drawing board or whatever I get through. I'll just check if that is possible. Then I think it's better to explain things in an easy way when you can draw the diagrams instead of just explaining like this. So this was just to complete the first chapter. Please go through this particular thing. I am getting very less time to complete it. I'm really sorry. If I would have got a lot of time, I would have definitely done it. At the end of the day, it gets a bit tiring, but I try to upload videos as much as possible. So whenever I will get time, I'll try to finish this as fast as possible. But I'll also try to make it more interesting for you so that you can, enjoy the classes. Wherever you are filling it out or wherever you want any improvement, do let me know. I know it is not up to the mark. I know it is not the best thing that you are getting, but I'm trying. I'm trying my best to give you what I can, so that it benefits a lot of students or candidates or whoever, they're in the field applying for this particular module. Okay, thank you so much.